Okay, so hello everyone. My name is Jens Müller. I'm a PhD student at the Chair for Network and Data Security at the University of Bochum, Germany. And I'm co-founder of a printer pen testing company called Printstack.io. And today I'm going to give you an introduction to our current research at the University of Bochum, a joint work on printer security. Now you may ask, why would anyone want to attack printers? Why does it matter to you? Well, who in this room has got a printer? Come on, raise your hands. Who has got a printer? Okay, everyone almost. So we still use them. They are everywhere. In almost any business, almost any household, any educational institution. And printers still have access to sensitive information that must be printed, like business contracts, like maybe yet unpublished research, like patient records, and so on. And today I'm going to show you how incredibly easy it is to access this information based on vulnerabilities that are present in almost any laser printer since 35 years. And apart from attacking the printer directly to get sensitive data on the device, the printer may be an interesting device to escalate yourself into a company's network, because it may be the weakest link in your IT security chain. So lots of motivation to have a deeper look at those devices. Now, undoubtedly, printers have evolved. 30 years ago, we had simple mechanical devices that did nothing but print or produce a paper jam from time to time. Nowadays, you cannot actually buy a computer, a printer, without buying a full-blown computer system. So you've got advanced operating systems, a TCP/IP stack, you've got often functionality such as fax and scanning. You can even install printer apps on some modern devices, so you've got package management right on the printer. So the only thing that may not have changed is that my modern device still tends to produce a paper jam always when I'm in a hurry and in situations when I really don't need that. So you may ask, well, all our devices are getting smarter and smarter. What is so special about printers? Well, apart from, or in addition to all the generic security problems that we have with embedded devices, with printers, there's something special. There's a security weakness by design that is shared by all laser printers. For example, you can access the printer's file system through ordinary print jobs. You can access the printer's memory sometimes through print jobs. Even firmware updates are deployed as print jobs. So there's no separation between administrative functionality to control the device and documents being printed. So basically, you've got data and code over the same channel, right? And that's always, we know that that's always a bad idea. And such a security weakness by design is shared by all laser printers. Okay, what are our main contribution of this work? We perform the systematization of attacks against network printers. Some of them are old news, well known, and some of them are pretty new. We evaluated the attacks on 20 printer models of different manufacturers using our Python tool, the Printer Exploitation Toolkit. And we showed some novel attacks beyond printers and some new research directions. So here's an outline of today's talk. First, I need to give you some basic technical background information to get a better understanding of the attacks to follow. Then I'm going to show you an evaluation of the attacks using our Python tool, Brett. And then I'm going to show you how to adapt the attacks to areas beyond printers, like to websites, for example. And last but not least, I'm going to show you how you can protect yourself from the attacks. Okay, let's start with some background information. What does it actually mean to print? Printing basically means two things. First, you need to choose a printing channel, like, USB cable or one of various network printing protocols, right? The second thing you need to do is you need to select a printer language, a language that is directly understood by the printer, like PGL or PostScript. And what your printer driver basically does is it simply converts the file you want to print into a language that is directly understood by the printer, like PostScript, for example. and sends it to the printer through whatever channel. So now, what can you attack in the context of a printer? What is there given a printer? You've got usually some kind of mechanical printing unit. We don't care about that one. What's more interesting is the printer language interpreters like the PGL interpreter, the PostScript interpreter, and there may be further interpreters like for PCL or direct PDF printing, or lots of proprietary printer languages that are supported by some devices. We don't really care about them. Now, when you want to print a document to USB, for example, you can send raw PostScript data to the USB port of the printer. It's interpreted by the PostScript interpreter and finally put to paper by the printing unit, right? And there are various other ways to print, like over the network, using raw printing, also called JetDirect, which means just sending the data to port 9100 of a network printer, which is supported by almost any printer out there. And the interesting thing here is that just like USB, you've got a bidirectional channel with the device. So you can directly talk to the PostScript interpreter, for example, which is great for information disclosure attacks. But there are various other channels you can use to print. For example, the Internet Printing Protocol is supported by most devices. It's used by AirPrint, for example. Then there is Line Printer Daemon, an older protocol known from the Unix world. And some newer devices support Server Message Block, which is known as printer shares in the Windows world. Anyway, the important takeaway here is that we don't care about the channels. We attack the interpreters, the PGL and the PostScript interpreters. And therefore, the attacks are independent of the channel. Whenever you can somehow print, you can perform the attacks I'm going to present here. And we focused our research on PGL and PostScript because those languages are so generic. They're supported by almost any printer, and they're pretty much mighty languages, so you can do a lot of evil stuff with them. Okay, let me give you an introduction to PGL. The printer job language was developed by HP in the early 90s, I think, and it soon became a de facto standard for print job control. Now, what can you then do with PGL? You can, for example, set the paper size to A4 and set the number of copies before switching the language interpreter to the actual page description language, which contains the document to actually be printed, like to PostScript, for example. And the interesting thing here is that PGL is not necessarily limited to the current print job, so you can use this to make permanent changes and therefore potentially influence further print jobs. And there are other interesting features in the PGL standard. For example, the standard allows you to access the printer's file system through PGL, through a print job. Well, this is really old news, right? This has been shown on exactly this conference 15 years ago by FX and CamZero of the Finolitech group. But still, even today, printers are vulnerable to this feature because they support it. For example, last month, Jacob Baines of Tenable showed how to root current HP OfficeJet Pro printers, for example, using this flaw that you can read and write to the printer's file system. And playing around with that device, I got from the Black Hat guys yesterday. Also, I found, I think, a 0-day on that device based on this feature, so maybe we should talk. Anyway, PostScript, the second language of interest. PostScript was invented by Adobe, the very first product of Adobe. Now, what is PostScript? PostScript, some of us may remember this as a format for document exchange, which has been replaced by PDF nowadays, right? But actually, PostScript was designed for and is still heavily used on laser printers. So when you want to print a PDF file, for example, even today, usually your printer driver converts it, for example, to PostScript and sends it to the printer. Now, the important takeaway here is that PostScript is not a simple page description language or markup language like HTML. PostScript is actually a Turing-complete programming language. So, from the viewpoint of theoretical computer science, given access to a PostScript interpreter already means code execution, because any possible algorithm or any possible program can be written in the PostScript language and executed on the printer. Okay, let me come to the attacks. Our methodology in finding new attacks was actually pretty simple. We systematically studied the standards of both PostScript and PGL, and we systematically looked for features in the language that are interesting from a security point of view and that may be used for attacks. Before I come to the actual attacks, I need to introduce 3 attacker models so you can see who is actually able to perform the attacks to follow. So our first attacker model is the attacker with physical access to the device. That is a quite strong attacker model, for sure. However, ask yourself, is your department's copy room really always locked? Are your Blackhat conference printers really never ever unattended? So actually, I got in contact with a security guard taking that photo, so maybe. Anyway, usually it's only a matter of seconds for an attacker to sneak into the copy room of a company and then, for example, permanently infect the device with PostScript malware by printing from USB stick. Okay, our second attacker model is the attacker with TCP/IP network access to the printer. Again, you may ask, who would connect his printer directly to the internet? Well, a lot of people do. These are current numbers from Shodan, the search engine for devices. And Shodan currently classifies about 35,000 computer systems out there as printers. Actually, it's a lot more. The classification here is not 100% correct. Anyway, given an attacker who just wants to randomly attack some devices, you can use Shodan, say device printer and country US, and she can find alone in the US over 10,000 printers to attack. Okay, how would the attacker do that? Well, the attacker would use the internet to connect to port 9100 of the network printer. And again, as said, there's a bidirectional channel using this port, so you can not only send data, you get also a feedback, you can leak information, and so on. So if there's some kind of firewall, as it should be, and the printer is not directly connected to the internet, then there are other scenarios that may be considered in this attacker model, like, for example, an insider who wants to read, for example, an employee who wants to read the payroll print jobs of the department manager on a shared printer device in the same local area network. But also, it's interesting that most new printers come with Wi-Fi enabled. And all the attacker has to do is run her own Wi-Fi access point with a default or service SSID. And many printers will automatically connect to that access point. And then again, an attacker who is physically close, but not within the company's network, can use the printer to attack the device itself and maybe even to escalate herself into the company's network. Okay, our weakest attacker model is the web attacker. All she does is she controls the content of a website. And she somehow manages to lure an employee within the same local area network than the printer to be attacked to her website. And then she can, using JavaScript, trigger HTTP requests to the printer. And for example, she can send PostScript documents to port 9100 that are executed on the printer again. Now there's one drawback with this attacker model. We can only send data. We cannot receive any data. We have no back channel. I will come back to that drawback later. Now let me come to the actual attacks. We categorized our attacks into 4 classes. Simple denial of service attacks, making printing functionality unavailable to other users. Bypassing protection mechanisms, for example, by resetting the device to factory defaults. Manipulating other users' print jobs, and information disclosure attacks, meaning access to the printer's file system, the printer's memory, or access to print jobs. Okay, now let me give you a few examples for each class of attack. So if you want to perform a denial of service attack against the printer, what will always work almost is the infinite loop in PostScript. So as said, PostScript is a programming language, right? And you can use all the features of a programming language like loops. And by sending this line of PostScript code to the printer, you will tell the printer to do nothing forever and efficiently get stuck, usually until the device is turned on and off again. Okay, fair enough. If you can print, you can prevent others from printing. We thought, well, can we do more? Maybe, well, can we try to physically damage the device? And yes, we can do that, because all long-term settings for embedded devices are stored in the NVRAM. The same for printers, of course. And the NVRAM, which is EEPROM or flash memory, has a limited number of write cycles, right? Usually it's 1 million or so, or even more, so you can't exhaust that. But on printers, with a single line of PGL code, within a print shop, you can change the settings, the long-term settings of the device, and therefore force a write cycle of the NVRAM. So by sending this line of PGL code to the printer, you can set the default value for the number of copies, for example, and you can also do that in a large print shop with 1 million lines and wait some time. And then again, you exhaust the NVRAM's capability sooner or later to accept new values. It's physically not possible to write to the NVRAM anymore. Well, not really a problem, because you can still perfectly fine print from the mechanical point of view. But for example, consider the default setting for the printer, for the paper size of the printer is A4, and you want to change that to letter, but you can't do that anymore, so that might be a problem. Also, you can't change passwords and so on anymore. Okay, so next class of attacks, bypassing protection mechanisms. Well, consider there's an administrator, and he did his job really well, and he secured everything, set passwords everywhere, even the printers are password protected. Now, our attacker wants to change some settings on the printer. That's hard. What she always can do is, if she has got physical access to the device, she can reset the device to factory defaults, right? By pressing certain key combinations, usually documented in the manuals. That's a feature. But what is maybe more interesting, that on some devices, for example on HP printers, you can reset the device to factory defaults using an ordinary print shop. So by sending this line of PGL code to the printer will restore factory defaults and therefore wipe away all passwords and other protection mechanisms. Okay, here's one of my favorite, manipulating other users' print shops. Well, how could we do that? One way to do it is to redefine the show page operator of the PostScript language. Now, you need to know that PostScript is a language that consists of about 400 functions called operators. And one interesting feature of PostScript is that you can permanently override features, operators of the PostScript language itself. So one of those 400 operators is the show page operator, and it must be contained in every page, in every document to be printed, because it tells the printer to actually put that page on paper. Now what the attacker can do is she can override this operator, hook in there, and therefore get her own code executed in subsequent print shops. This can be used to overlay arbitrary graphics, for example. Let me give you a demo. Okay, this is now our printer. Thanks to the Black Hat guys for giving me this device to play around with. And this is our tool. Brett, if you call it without any arguments, it will just try to discover local printers using SNMP. And now you can connect to the device using various modes, for example, in PostScript mode. Hope it works. Yep. And as you can see, we are now connecting over port 9100 to the printer. We got a bidirectional channel, that's great. We've got lots of commands that we could try. In this case, we want to do some overlaying. So let's say overlays, Black Hat. Now we have infected the device with PostScript malware, and now we are printing some text form that I sometimes need to fill out. I just print it using my normal printer driver in the operating system. It's a PostScript-based printer driver from CUPS. And what now happens is that The document is normally processed by the printer, but when the show page operator is reached, our code is executed, and as you can see, there's a plaquette on that paper. And this is a 35-year-old function of the PostScript language, actually. So it works on all PostScript devices. Okay, okay, that's simple pranks, right? But maybe you can do more. And for example, be creative. You're in the context of an actual programming language. So we can, for example, also in subsequent print jobs replace the strings in the documents. So you could, for example, introduce misspellings into the print job of a certain user that you don't like. Or you could lower the price in a sales agreement, for example. And yeah, here it gets ugly, I think. Okay, last class of attacks is the information disclosure attacks. As said, you can, using some proprietary extensions of PostScript and PGL, access the printer's memory sometimes. But accessing the file system is even a part of the standard of both printer languages, PostScript and PGL, excuse me. And yeah, what I'm going to show today actually was capturing print jobs, right? Okay, using the very same technique like before, that we can hook into subsequent print jobs and get access to subsequent print jobs, we can in theory, of course, also capture all print jobs. That's what we thought. In practice, actually, this was very hard to implement because there are lots of challenges to solve. For example, where do you actually store the print jobs? If you have got a hard disk, you can store them there. Else you need to store them as PostScript variables in memory. Okay, let me give you a demo. So again, we connect to the printer. We use the capture command. We are infecting the device. Now we are again printing that form. And the attacker waits maybe a day or a week. If the device isn't turned off, it's no problem. And then he comes back later that day, connects again to the printer, and uses capture list. And I hope, yep, there is the print job. And we can fetch it, of course, and download it. So it's 200 kilobyte, this form. This is not too big. I think the printer has 128 megabyte of memory, so you can get a lot of print jobs captured before the memory fills up. And you can now, using the bidirectional channel, download that file. And it's a PostScript file that is exactly in the structure that it was processed by the printer, and you can open it with any PostScript viewer like Evans in Linux, for example. Ta-da! We've just captured the form. Okay. So, as said, with information disclosure attacks, there's a problem with the web attacker. Well, if you have got physical access to the device, you can use USB cable, get a bidirectional channel, do information disclosure attacks. If you're a network attacker, you can use port 9100, get a bidirectional channel, again, do information disclosure, obtain print jobs. The web attacker can't do that. She can only send data to the device, but not receive any data. A malicious website cannot access the results. Why is this? You all know why this is. This is because of the same origin policy, right? Scripts can only access resources from the same origin. Short example, you've got evil.org and some internal banking site you want to attack using the employee's web browser as a carrier. You lure the employee's web browser to your website, and then you can execute JavaScript in the employee's web browser and therefore force HTTP GET requests, for example, to some internal banking site. But now the employee's web browser says, wait. Evil.org does not equal internal.bank.com. So you're not allowed to access this resource, right? That won't work out. However, in the context of printers, we can abuse some new features of the web. For example, we can use CORS, cross-origin resource sharing. What can you do with CORS? You can bypass the same origin policy if the web server explicitly allows you to do that. In the context of printers, however, we can post a PostScript file to port 9100 of the printer through the employee's web browser, right? Now, a PostScript file is a programming language. It's executed on the printer, and PostScript allows you to do arbitrary echo statements to echo back to standard output to the network channel. Oh, that's great. What can we do with that? We can simulate an HTTP server that is running on port 9100 of the printer. These PostScript commands are echoed by the printer, and now the employee's web browser thinks, oh, it's a web server that is running there, great. Well, and there's access control, allow original-evil.org, that's great. So this website explicitly allows evil.org to access the data, and again, we got a back channel. So in other words, the malicious website can perform all the information disclosure attacks. She can read your print jobs. And it's really pretty easy and pretty practical. We've put up a demo on hacking-printers.net. Okay. Now let me show you an evaluation of the attacks. One problem was obtaining enough test printers. We actually wanted to have printers that are used in a typical university or office environment. And well, how would you actually get those devices? What we did in the end was we knocked a lot of doors at the university and asked the system administrators if they wouldn't give us some devices for science. And that worked out pretty well in the end. We got 20 devices from 8 different manufacturers. So here are the results of the evaluation for the denial of service class of attacks. On the left side, you can see the printer manufacturer. And red always means the device was vulnerable. So I said, what always works is the infinite loop in PostScript. But there are other possibilities to cause denial of service attacks, like, for example, you can redefine the show page operator to do nothing at all. So print jobs are still processed, but they're not put to paper anymore. And PGL has a similar feature that allows you to put the printer into offline mode, so you cannot connect to it anymore through the network. And on 8 devices, we were even able to cause physical damage to the NVRAM through print jobs. Next class of attacks are restoring factory defaults and therefore bypassing protection mechanisms. Using SNMP, this worked for about half of the devices. It was the only attack that was not performed through a print job. But on HP, for example, you can also do that through an ordinary print job, probably also on other manufacturers if you got access to their proprietary PGL commands. Overlaying content or replacing strings in subsequent documents worked for most PostScript-based devices. We couldn't test 3 devices because they had physically broken printing functionality, so we simply couldn't test them. Accessing the printer's memory worked for Prada-based devices. What we could do there is dump the device passwords, for example, but also if the device was integrated into the network, we could see the scan to emails or the email credentials. Even you could integrate those devices into a Windows domain, so we found the Active Directory passwords there. So pretty interesting stuff. Accessing the printer's file system only worked for 2 devices to access the whole file system with both PostScript and PGL. On the other devices, we could only access certain directories. Now, this is not harmless because there's often more than just some fonts and some boring stuff. For example, on Oki devices, you'll find a directory there that is called hidden, and they're all the settings for the device, and you have read and write access to it. It's not only the passwords for the device itself, but again, it's the passwords for scan to email to get email credentials, scan to FTP. There are even LDAP passwords sometimes, or the Wi-Fi and the IPsec pre-shared keys can also be found in that directory. So capturing print jobs worked on most PostScript-based devices. On some devices, we didn't get a back channel, and on Prada-based devices, for example, we were unable to do the attack because Prada is not compatible with the Adobe PostScript standard, actually. And brute force attacks against PostScript and PGL also worked for most of the devices. Anyway, the important takeaway here maybe most attacks work on most manufacturers because it's just that those languages like PostScript and PGL are supported by most languages. So it's not a bug, it's a generic problem of all printer manufacturers. Okay, now let me show you our Python tool, Bread. What can you do with Bread? You can pen test printers. It's free software available on GitHub. There's even a Placket release I published some days ago. Now, if you want to test your printer, what you can do is you can type ls into Bread, for example, and it's parsed by the attacker component and translated either to PGL or to PostScript, and then it's sent to the printer using USB cable or currently supported port 9100 of network printers. So, for example, if you want to talk to the device in PostScript mode, you don't have to speak PostScript directly, you just type ls and it's translated to a PostScript request and you get a PostScript response of the directory listing, and that one is shown in a user-friendly manner in Bread. And the same for PGL, you type ls, get send a PGL request and get a response, and again you get the results of the directory listing on the printer. So here are some of the commands that are supported by Bread for accessing the file system. It's the typical commands you would expect from a command line FTP client, for example, like ls, get, put, delete, and so on. But there's a lot of more commands to discover because we have implemented all the attacks into Bread commands. Okay, now we thought maybe can we adapt the attacks to areas beyond printers? And for PGL, this is actually pretty hard because PGL is pretty tightly bound to printers only. However, PostScript as a document format is used in various areas. For example, Microsoft Office and LibreOffice, they allow you to import PostScript files, and therefore you can potentially attack desktop software. And even some top websites to execute PostScript. I will come back to that in a minute. Now first let me show you how to attack Google Cloud Print. What is Google Cloud Print? You can use this to print from everywhere in the world. You maybe have used it if you ever printed from your Android phone. So what can you do with Google Cloud Print? You can attack the printer. If it's a PostScript printer, you can simply send a PostScript file, a malicious file, and the cloud will just forward that to the printer. It's executed on the printer, and hey, we've got yet another channel to perform the attacks. Great. But maybe we thought, can we do something else? And maybe we can attack the Google Cloud directly. So you need to know that Google Cloud Print, is a driverless printing. So you just send any kind of file format, and it's converted to the corresponding page description language supported by that printer. So if the attacker registers a printer that says, hey, I don't speak PostScript, I'm a PDF printer, I only accept PDFs, give me PDFs. Now, if we send a PostScript file to print using our Google account, it will be converted to PDF, right? However, converting PostScript means actually interpreting PostScript, means executing PostScript in the Google Cloud. In the end, the danger was limited because, well, the Google guys are pretty bright, right? And they had sandboxed everything, and all we could do was some limited information disclosure by doing stat system commands into their real file system, so really, really limited damage. Anyway, we got some reward for that finding. Okay, then we thought, well, can we do more? Are there other areas where PostScript is used in the web, for example? The next logical step here was to look at PostScript to PDF conversion websites. And there are not that many out there. However, those that exist, they are usually vulnerable to at least information disclosure attacks, sometimes even more. So we thought, can we extend it maybe? And we could extend it to image conversion websites in general. Why is this? Because image conversion websites, they often accept EPS files. Now, what is EPS? EPS is known as an image, vector image file format, however, actually contains just plain PostScript in the end. And we recently tested the 100 online image converters and found 48 of them to be vulnerable again to executing PostScript. And okay, now you may say, okay, my website, we don't do any image conversion, right? But maybe you allow your users to upload profile images and you resize them on the server. Then again, you do image conversion. Or maybe you allow your user to upload a file, for example, in the context of a web mailer, and then you create a thumbnail preview of that. And then again, you do image conversion. And then again, you must be careful not to accept PostScript files. So I hope I can give you a demo. I hope I'm online. Let's attack Dropbox. Are we online? Oh, damn. Okay. So the cool thing with Dropbox is that it allows you to directly upload EPS files. So we do not have to play around with the content type or change the file extension or so on. We just directly get an EPS file, which should be there now, but it isn't. There it is. And what you can see here is actually a PostScript file that was uploaded, which contains code which generates a dynamic output of a directory listing on the Dropbox server. Okay? So this is not a problem for Dropbox, again, because they sandbox all their conversion process and they made us, it's not a security problem. They have containers and sandboxes for this thing, so it's not a real file system. Anyway, not all sites probably have all these additional layers of security, especially if your website uses ImageMagick in the background, which many frameworks do. They very often accept PostScript files, and then it gets dangerous. And we have published a cheat sheet where a dozen of PostScript attacks are automatically executed. You just need to upload that file. It's on our GitHub repository, and it will automatically try to launch the attacks. Okay. Now, let me come to some countermeasures. How can you actually protect yourself? Well, it's actually kind of hard because we attack the standards that are used for printing itself. We only used legitimate features of the PostScript language that is used for printing itself to capture print jobs. So in the long term, actually, we need to get rid of insecure printer languages. But that won't happen probably in the next years. So what else can you do? You can mitigate it on the network level, of course. So make sure that your printer is never ever connected directly to the internet. There was an incident in February where some gray hat hacker printed ASCII art on 160,000 printers around the world. That's quite harmless, I would say. The guy could have done really bad things like trying to physically destroy the printer or the printer's NVRAM or try to obtain print jobs. So especially if you have a university background and so on, where all devices still get public IP addresses, make sure your printers are not connected to the internet directly or reachable from the internet directly. What else can you do? Well, make sure your employees always keep the copy room locked, so to not make it too easy for an attacker to get physical access to the device and therefore infect it, for example, with PostScript malware. Administrators, they should consider sandboxing their printers into a separate VLAN that is only reachable through a hardened print server. The print server must be hardened because else we can attack the print server using the PostScript attacks. And that's currently the only possibility to really mitigate those attacks. Now, printer vendors, well, they should consider in the long term undoing some insecure design decisions that have been made, like PostScript, like proprietary PGL features, or like data and code over the same channel. I mean, it's not their fault in the end because those languages existed 35 years ago. So, and now we have the web and all those things, and we have just other channels to exploit it. And if there are any browser vendors, consider blocking port 9100 added to your list of blocked ports. It's really not your fault, but you can really block cross-site printing, so you can block a web attacker, a malicious website to obtain the print jobs. Okay, of course, in the long term, it's up to the printer manufacturers to produce secure devices. Okay, so let me come to a conclusion. Christian Slater, maybe you met him yesterday. I think he was pretty right in that video. Maybe you saw it. Printers are really, really damn insecure. And why is this? One of the reasons is that PostScript and PGL is supported by almost any printer, and it's really, really dangerous. It's dangerous languages, it's legacy code that can be executed on the printer. And nowadays, we can exploit this through lots of channels. Whenever you can print, you can exploit the device, and even websites can do that. And currently, we do not have any real countermeasures to those problems because it's actually a problem of the standards mostly. So we can mitigate it on the network level, but that's not perfect, I'd say. Okay, let me come to an end of the talk. The tool I showed you, Bread, is freely available on GitHub. Use it to test your printers and give me some feedback. And if you're interested more in the technical details of the attacks, we have set up a wiki, hacking-printers.net, where all the attacks are explained in depth. Okay, do you have any questions?
Hello? I have a question. Hi. Some printers supports .1x for authenticating into network switches. Are you able to use this printing language in order to steal the certificate installed on the printer?
The answer, as a short answer, no. Not in a generic way. So what we did is we used generic languages to do generic things like capture print jobs. And on some printers, actually, we were able to extract the printer's SSL certificates using features like PostScript-based file system access. But this is pen testing of certain models and certain implementations. So it's not, you can't do that for all devices. It's not that easy. But sometimes, yes.
Okay. Some companies offer print control. So the printing goes first for the server and only then to the printer itself. Is it a good way to defend yourself?
Yeah, actually that's what I meant with make your printers, get your printers into a separate VLAN and make sure there's no direct connection to the printers, and then use a hardened print server, so another system that cannot be attacked through malicious PostScript, also be careful here. Then you can mitigate all the attacks. So the printer is still vulnerable, but I'm not able to deploy my malware anymore.
Hello. I didn't see any test cases on Zenrox, which is widely used. And I was wondering, how did you figure out the test case with Zenrox? And also, if you didn't find any vulnerabilities with Zenrox, what protections did they do?
Xerox?
The Zenrox printers.
No. Xerox is also vulnerable. We have, all of them are vulnerable because all of them speak PostScript. We just didn't have a single Xerox printer to test to publish this paper. So we didn't get a Xerox printer. We later came to Xerox printers to test, and they're also vulnerable. But we couldn't get that into that table.
Okay, got it. Thank you.
Okay, if there are no more questions, thanks again.